We're now going to find the optimal solution out of our feasible solution set. So once we have a feasible solution, all we need to do is figure out which one's the best one. So remember, this is our problem with our farmer and his corn and his soybeans, and we already found our objective function to be the profit is equal to 50x plus 40y. We already found our constraints, and we found our feasible solutions now to be the following. And so I've rewritten the maximize profit function because we're trying to maximize our profit. And what we're going to do is we're going to calculate P with these four values. So we're going to use the 0 to 40, and this is going to be P. So here's our input, and here's our output. And we're going to do this for every corner point that we had. 160 and 0, and 0 and 0. So I'm going to get out my calculator, and I'm going to do 50 times 0 plus 40 times 240. And that gives me 9,600. So if all I do is my soybeans, I'll make $9,600. Well, what about 50 times 80 plus 160, oops, let's do it right, 40 times 160. So if I do 80 corn and 160 soybeans, then I'll make $10,400. Well, let's do 50 times 160 plus 0, no, we should do this right, 40 times 0. We'll only make $8,000 if we spend all of our time and acreage on corn. And the last one, if we don't do either, this is real easy. 50 times 0 plus 40 times 0 is 0. Oh, I missed a 0 there. That was 8,000 and 0. So I find my profit for my different corner points, and then I come in, and because I'm doing a maximum problem, I pick the maximum, which means my optimal solution is to do 80 acres of corn and 160 acres of soybeans, and I will maximize my profit for my time spent on those crops. If it said minimum, I would have taken the other choice, and I would have come down here and I would have grabbed my 0, because if I was trying to minimize profit, or let's suppose this was cost instead, then I'd want to pick the 0, 0 to minimize my cost.